Hello class again and welcome to this particular video, and in here we're going to be exploring the basics of physics, and this is going to be focusing on kinematics. And you might be wondering, what is kinematics? Kinematics is considered to be the study of motion, and when you study motion, kinematics, we need to consider various things in this particular aspect of kinematics where we are studying motion, and motion has to be divided into, in this case, what is one. The definition of motion. Motion is considered to be the following. In here, we're looking at the change in a specific object, and this particular object has to be with respect to a specific location. And so, once we have the specific change in the object's location, this has to be done based on this particular measurement gotten from an observer. And once this measurement is taken from an observer, we are able to define the motion of a specific object. And so, looking at this, there are two things you need to keep in mind in terms of the quantity of objects that are expressed in terms of the measurement. And the two types of quantities that we are going to be exploring are: one, we need to differentiate between what it means to be in a scalar state versus that which is a vector state. And what does it mean when a specific quantity is a scalar quantity versus when a particular quantity is a vector? So take note here that for you to be a scalar quantity, you need to have a specific size, which means you must have a magnitude. And this is different, of course, based on one other property, which is that there is no direction. So you can measure the direction, but you can only measure the magnitude, which is defined as a scalar quantity. And some illustration would just be this image. This image that you see right here just shows you the length of this particular line from one point, in this case we call it point A, to point B, and we usually express this as a line segment. And a line segment is just telling you what point from one location to another is, but it doesn't tell you where specifically in one location it is, whether it's north, south, east, west. However, on the other side, a vector quantity do have magnitude, and it has, in this case, a direction. And so what makes this vector quantity different from the scalar quantity is that although both of them do have magnitude, which means that you have a measurement scale, you don't have direction for the scalar quantity. However, a vector quantity do have a direction. And so, based on this, we have an example where, in this case, we are dealing with a directed line segment. And a directed line segment, in this case, actually tells you what is the tail, which is where you're starting, and where you are ending, which is, in this case, the head. And so, in this case, you could have from point A going to point B, and this could be somewhere around the coordinates, which is somewhere around the southeast direction, or east, particularly, if you want to go accurately in terms of the location. However, you can also take note, define this as BA when you have the specific starting point to be at B and going to A. So in this case, A is the head and B is the tail. And so where this particular line, directed line segment, is considered to be from A to B with your arrow at the top, from B to A with the arrow at the top is the other way around. And so take note that this expression is considered to be the directed line segment. So once we have this established, let's look at what other ways by which scalar quantity differs from vector quantity based on motion. And take note that the motion we're talking about here is just a straight line motion. So for a scalar quantity, one example of a scalar quantity is using a specific known example to be called distance. And so distance here is represented as this particular variable, which is d only, and it is measured, take note, in meters. And take note that this is expressed as the total length of a specific path that is based on the traveled object. And so when an object is traveling, you actually just measure the path that that particular object takes in motion. And so in this case here, for example, if I have an object starting from here and making a circular path and ends in that same location, and the circular path is measured to be 20 meters. In this case here, our specific distance that is made by the object is 20 meters. This doesn't tell you the direction specifically. However, a comparison with vector would be another quantity that is considered to be a vector quantity is called a position. And so a position indeed is represented as d, but take note that there is an error which tells us that d is a vector quantity. And so d as a vector quantity is represented as the position. And so take note that the position is not only measured in meters, but also it is measured based on the location it is in. And so the location is based on the coordinates, which is based on the compass, where we have our north, we have our east, we have our south, and we have our west. And so wherever the arrow is pointing towards around the coordinates do tell us the specific direction our specific object is located at. So take note here that in here we're describing not only the distance, which is what we just talked about, which means the total length path traveled by the object, but also you're talking about the other quantity variable, which is in this case the direction. And so this is what we talked about here based on direction, and here is where it's actually applicable to position. And so an example is that this here measurement of the distance and the direction has to be based from a specific reference point, and our reference point is the observer, which is in this case you looking at an object moving in a specific direction. And so in this case here, for example, if I have an object that you observe at this particular point moving to this particular direction here, and it stops right here, this here is the new position, and the new position is the expression of not only the distance that is made by the object, in this case we consider it to be 20 meters, but also the direction, which means that where is the head pointing at. And so in this case the head is pointing in the north direction. And so when you rewrite your position, you're rewriting it as, in this case, our position, which is represented as d with the arrow at the top, is equal to 20 meter in a bracket the direction, which is, as we see right here, which is represented as north, which is based on this particular diagram. So in here, take note that this position is actually a property that links really well with another vector, and this vector here we're going to talk about is called displacement. And so displacement is based on our specific understanding of what position is. And take note that the displacement is expressed as the change in the specific position of an object, which is in this case change d with the arrow at the top. So take note that this can be determined in this particular formula state, where the change in the position, which is represented as change in D to the arrow is equal to the final position minus the initial position of your specific object. And so this is when you're looking at just one motion. However, if you have an object that changes position more than one time, so in this case, for more than one time for the position, we have the other way around where we have a specific final displacement, which is in this case expressed as the total displacement, to be equal to the sum of the change in the positions. So in this case here, the change in position, which is displacement 1, plus we have another displacement here, is a vector, in this case 2, and we have this particular arrow at the top. And all these take note of here is that they could be positive or negative values depending on the coordinates that you assign right here. So if you make north to be positive, then it means that the change in position here will be positive. However, if the change in position here, which is in this case displacement for D2, is negative, it means that the opposite in direction of north is south, which means that you're going to have a negative value for your quantity, and that is going to affect your total displacement, which is when you have more than one movement. And we're going to talk about this when we talk about various examples in this particular case right here. So I hope you found this really informative in terms of not only comparing scalar quantity with vector quantity, but also introducing you to kinematics and motion and how we're able to differentiate scalar and vector quantity based on the magnitude and direction, and differentiate it between distance, position, and displacement. So please keep these relationships in mind. We're going to talk about this in detail in our next examples, and also how we're going to build on this to talk about speeds and velocity. So thanks for following me through this. I appreciate it. Please let me hear your thought about this. By that way, I can talk to you all soon. Stay smart as always, and believe in yourselves.